I like refraction problems. I just think they're kind of fun, and when you build in more layers than what I got here, then you have a pretty interesting calculus problem to solve. Anyway, let me describe this problem, and I have one similar to this in my book. Without using a bunch of words writing down, I thought I would just verbalize this one. All right, you're at point A on the road, and you want to get to point B off the road. And it's 400 feet along the road, and it's 150 feet back in the property. And the problem is that this is deep sand, very loose sand, so you can't walk very fast in it. And let's say you can go 3 feet per second. So if you've walked around the natural sand dunes in Florida, as I have, there are not too many of those left, by the way. You know how slow it can be walking in deep sand. And along the road, 6 feet per second, actually that's pretty fast. That's about around 4 miles an hour. But I wanted to use a little bit different numbers than what I use in my book. Alright, so the question becomes, write a function describing the time it takes to go from point A to point B in terms of a point X along the road from which you turn off the road and walk toward point B. Alright, so let me put my point X here. Here's X. And what I really mean is that this is length X. And so we're going to walk a distance of X units along the road. And X is anywhere from 0 to 400 feet, isn't it? The domain of this function for X will be between 0 and 400, because you would not walk backwards and you wouldn't walk past it. And so the domain is restricted, in that case, from going directly, which would be X equals 0, or walking all along the road and then going vertically, which would be X equals 400. Alright, so we travel X feet this way, and then we head toward B. Alright, so the question becomes, write the function describing the time it takes to go from A to B in terms of this X. Alright, now if you were to ask the question, what's the fastest way to get there? There are 3 reasonable answers. Reasonable answer 1 is to say, well, the shortest distance between 2 points is a straight line. I'll just go all along the sand. Reasonable solution number 2 is, well, look, it's a lot faster walking along the road, so I'll just walk along the road as far as I can before I have to walk along the sand, so I'll make the sand distance the shortest. So that's reasonable solution 2. Reasonable solution 3 is somewhere in between. And so to answer that question, what's the fastest way, we're going to need to define it in terms of X and figure out where along here our fastest solution is. Is it directly from A to B? Is it all along the road? Or is it in between? And you could probably guess it's going to be somewhere in between. It is. Alright, so anyway, I'll write this function, and again, unfortunately, the best part is the calculus. Where we can answer the question, what's the fastest way? We can't answer that in this course. All we can do is just set up the function. And so that's what I'm going to do. Alright, well, we're adding up times, aren't we? So we want to know how long will it take in terms of X? Alright, so I want the time in terms of X. So let's make it f of X equals to the time in seconds based on X feet past A. Alright, so time in seconds. Well, we know how fast we can walk along the road, so the time along the road